This is Dreamtime Science, where we paint the canvas of your dreams with the soft brushstrokes of scientific wonder. Together we'll explore the mysteries that dance at the edge of consciousness. You know what's fascinating? I've been thinking about how our entire solar system isn't just sitting still out there, it's actually zipping through the galaxy at incredible speeds. It's a bit like being on a cosmic roller coaster, and tonight I want to share just how fast we're moving and what that means for us, which is a surprising and beautiful story that feels almost like a secret dance among the stars. If this peaceful blend of science and serenity helps ease your evening, consider joining our community of gentle learners. Share your favorite moment of scientific awe in the comments. First, let's create the perfect space for learning. Cocoon yourself in comfort, release any lingering tension, and let your breath become soft and steady. Beneath the velvet spread of midnight, when the world outside hushes its daily bustle and the gentle hum of night becomes a lullaby, there is a peculiar comfort in gazing up at the sky. The stars, so sharp and steadfast, seem to pin the heavens in place, each a silent sentinel. Generations before us have looked upon these same patterns, seeing in them the stories of gods and monsters, of lovers and hunters, a tapestry of myth woven into the darkness. The sky, for so long, has felt immutable, an eternal backdrop against which the small dramas of human life unfold. Yet, this impression of stillness is as much illusion as it is inheritance. For all their apparent fixity, the stars and planets are anything but stationary. They are dancers in a cosmic waltz, each tracing a path through the galaxy, each bound to the others by invisible threads of gravity and time. The notion of a static universe, so intuitively appealing, is both a comfort and a misconception. It is tempting, after all, to believe in a fixed center, a place where we might plant our feet and declare, "Here I am, unmoving, while the world turns around me." But the truth is far more exhilarating and infinitely more profound. Science fiction, with its rockets and starships, has long played upon this hidden dynamism. In the pulsing heart of every epic voyage, be it aboard the gleaming decks of the Starship Enterprise or the battered hull of the Millennium Falcon, there is an implicit understanding that nothing in the universe is ever truly at rest. Heroes leap from world to world, galaxies spin in the background, and the very fabric of space seems alive with movement. Yet outside these tales, an older story lingers, the idea of a universe that is still, with Earth at its center, unmoved, while the cosmos revolves around it. This belief is not new. For millennia, humankind imagined itself as the axis upon which all else turned. The ancient Greeks, and later the scholars of medieval Europe, pictured a perfect crystalline sphere, studded with stars, spinning serenely around our world. To their eyes the heavens were an orderly clockwork, the planets set upon circular tracks, the stars forever fixed in place. It was a universe of certainty, comforting in its immobility, one in which the ground beneath our feet was the one true constant. But that certainty began to crumble under the weight of observation. The first cracks appeared when astronomers noticed peculiarities in the motions of the planets, those wandering stars that seemed to defy the perfect circles prescribed by tradition. Mars, in particular, played the trickster. Night after night, it would drift backward against the stars, looping in a retrograde dance that no model of celestial spheres could adequately explain. The sky, it seemed, was less a well-oiled machine and more a stage for a restless troupe of performers. With the advent of the telescope, the illusion of cosmic stillness was shattered. Galileo's lens revealed moons circling Jupiter, their orbits a silent testimony to the fact that not everything circled the Earth. The Copernican revolution, gentle in its mathematics but seismic in its implications, placed the Sun at the center and set the Earth spinning in its own grand orbit. Suddenly we were passengers, not rulers, carried along on an invisible current, our planet sailing through the void with a speed and grace that belied the solidity of the ground beneath us. But even this model, which felt so daring in its time, only hinted at the true scale of motion that pervades the universe. For just as the Earth orbits the Sun, so too does our entire solar system trace a path around the heart of the Milky Way galaxy. We are not merely circling a single star. We are part of a vast, spiraling congregation of hundreds of billions of suns, each one following its own arc through the galactic night. Imagine, if you will, standing in the center of a dazzling carousel, not the painted wooden steeds of a country fair, but a carousel wrought of stars and nebulae, stretching across 100,000 light-years. Our sun is just one among the countless lights affixed to this great wheel, and we, clinging to our fragile planet, are carried along for the ride. The galaxy spins inexorably, its arms trailing like the skirts of a cosmic dancer, and with every turn we are swept through clouds of interstellar dust and the faint, ghostly remnants of ancient supernovae. The speed at which we travel is almost beyond comprehension. As the Earth orbits the Sun at roughly 30 kilometers per second, fast enough to circle the globe in under half a minute, the Sun itself, with all its planetary retinue, races around the center of the Milky Way at a staggering 220 kilometers per second. If you could somehow mark a point in empty space and watch as we passed by, you would see our entire solar system hurtling along, the planets spinning in their orbits like dancers twirling in a waltz atop a moving stage. And yet, from our vantage point here on Earth, nothing of this motion is apparent. The stars overhead seem fixed, their patterns unchanging year after year. We do not feel the rush of cosmic wind against our faces, nor the trembling of the ground beneath our feet. The reason for this lies deep in the nature of motion itself, a lesson that Galileo, with his inclined planes and rolling spheres, was among the first to articulate. Motion is relative. To those of us aboard this celestial carousel, everything seems at rest because we, the ground, and the air we breathe are all moving together, swept along by the same invisible current. It is only when we look outward and measure with careful eyes and precise instruments that the truth reveals itself. Astronomers, armed with telescopes and the mathematics of celestial mechanics, can track the shifting positions of stars and galaxies across the years. They see the subtle drift of our solar system through the galaxy, the gentle tug of gravity as we are pulled toward neighboring clusters, the grand expansion of space itself as distant galaxies recede ever further from our view. The myth of a stationary cosmos lingers, perhaps, because the evidence of our senses is so persuasive. When we sit quietly beneath the stars, the world feels still. The air is calm, the grass unmoving, the great dome of sky unchanging. But the universe, in its restless grandeur, is not obliged to move at a pace we can perceive. Far above us, the sun's gravity holds the planets in thrall, guiding them in silent ellipses around its warmth. Further still, the gravity of the galaxy binds our solar system to a far vaster orbit, one that takes more than 200 million years to complete a single revolution. To put this in perspective, consider that the last time our solar system occupied its current position in the galaxy, the dinosaurs had only just begun to roam the Earth. The continents were arranged differently, the climate was unrecognizable, and the ancestors of mammals were small, furtive creatures scurrying beneath the ferns. In the time it takes for the Sun to complete a single galactic circuit, life on Earth is utterly transformed, a slow, stately revolution that plays out against a backdrop of cosmic change. This journey is not a simple loop, but a complex, undulating path, shaped by the gravity of passing stars, the pull of dark matter, and the subtle ripples of spiral arms. Our solar system bobbles gently up and down as it circles the galactic center, crossing the thin disk of the Milky Way every few tens of millions of years. Some astronomers have speculated that these crossings might even influence the course of life on Earth, as gravitational perturbations stir up comets in the distant Oort cloud, sending icy messengers hurtling toward the inner solar system. The sense of movement, then, is woven into the very fabric of our existence, though it is hidden from our daily experience. We are, all of us, riders on this cosmic carousel, carried through the darkness by forces we can scarcely feel, on a journey whose scale defies imagination. The universe is a symphony of motion, each note a planet or star or galaxy, each measure spanning eons. It is humbling to realize that the very concept of stationary is in the end a matter of perspective. To an observer on Earth, the ground feels fixed, the stars immutable. But to an observer light years away, the sun and its planets are just one more moving part in a galaxy alive with motion, a pinprick of light tracing a slow, spiraling path through the void. And to the galaxy itself, even the stars are restless, swirling together in eddies and currents, swept along by the gravity of unseen masses. The stories we tell ourselves of fixed points and unmoving stars are comforting, but the reality is richer and more wondrous. We are not at the center of the universe, nor are we stationary within it. We are travelers, borne along by currents of space and time, our every moment shaped by journeys both visible and unseen. In this light, even the familiar rhythm of day and night takes on new meaning. The turning of the earth, so regular and predictable, is just one motion among many, a small rotation within a grander whirl. The sun rises and sets not because the heavens move around us, but because we are spinning ever eastward on a tilted axis. And as we spin, we orbit. As we orbit, we are swept along by the sun's journey around the galactic center. And as the galaxy spins, it too drifts, pulled by the gravity of other galaxies, carried along by the expansion of space itself. The universe, it seems, is restless by nature. There are no fixed points, no absolute stillness. Even the most solid-seeming objects, the mountains, the continents, the stars themselves, are in motion, carried along by invisible hands. The comforting illusion of stasis is just that, an illusion born of our own limited frame of reference. And so, as you lie in the gentle quiet of night, held by the gravity of your own bed, you are moving through space at inconceivable speeds, borne along by a dance that began long before you were born and will continue long after you are gone. The stars above, though they seem unmoving, are fellow travelers, each following its own unique path, each a note in the endless song of the cosmos. What, then, does it mean to be at rest? In a universe of constant motion, perhaps it is enough to simply be aware, to recognize our place on this spinning, soaring world, to marvel at the hidden currents that carry us all. The carousel spins, the galaxy turns, and we, tiny and impermanent, are part of its endless journey. And as the carousel carries us onward, past nebulae and clusters, through clouds of dust and the shimmer of ancient starlight, one cannot help but wonder what further mysteries lie ahead, concealed by the darkness, waiting to be revealed as we ride the currents of the Milky Way. The journey continues, and with it the promise of discovery, unfolding, unending, just beyond the horizon of our sight. If you were to float far above the plane of our solar system, far beyond the reach of planets and comets, letting your mind's eye drift to a vantage point rarely granted to human senses, you would see something remarkable. What appears, through the lens of a telescope or the diagrams in a classroom, as a tidy clockwork of planets circling a stationary sun, is in truth a much more elaborate and dynamic ballet. The very foundation of our understanding, the idea that the sun itself is fixed, a fulcrum about which all else revolves, dissolves, replaced by a vision of ceaseless, spiraling motion. From this great and silent height, the sun is not a monarch enthroned, but rather a traveller. It hurtles through the galaxy at tremendous speed, trailed by its retinue of planets, comets, dust, and icy fragments. Each member of this celestial family orbits not merely the sun, but also follows it in its journey through the Milky Way's immense embrace. As the sun moves, it draws its planets along in a graceful, continuous spiral, each world spinning and turning in its own way, yet never losing the thread that binds it to the solar heart. The solar system is a whirling, coiling ribbon, weaving its way through the galactic darkness. The sun's journey through space is anything but idle or slow. Imagine, for a moment, the measure of its stride. Our sun travels at about 220 kilometers per second as it orbits the center of the Milky Way galaxy. In the time it takes for a single heartbeat, the sun has already swept more than 200 kilometers along its galactic circuit. In the span of a year, it covers over 7 billion kilometers, a distance so vast it can scarcely be grasped, even by minds accustomed to the language of millions and billions. But this is only the beginning of the great interplay of motion. Planets, too, are in constant flight, their paths curved by the invisible hand of gravity. Earth, for example, orbits the sun at about 30 kilometers per second. This means that as you lie in bed, you are carried through space faster than any jet or rocket ever built, faster than any bird, faster than thought itself. The very ground beneath you is a vessel racing around the sun on an endless path, but that path, too, is no simple circle. It is a helix, a spiral wound through space, for the sun's own movement adds an extra dimension, a forward rush through the galaxy, with the planets swirling behind in long, looping threads. Pause for a moment to dwell on this. You are never truly still. The illusion of rest is granted only by the relative calm of your immediate surroundings. In the cosmic theatre, everything is in motion, and the scale of that motion defies the limits of ordinary experience. Even the most profound tranquility, a night in the countryside, the hush of a snowy field, the gentle sway of a boat, rests upon a stage that is itself spinning, tilting, careening through the heavens. What force sets this dance in motion? At the heart of it all is gravity, the quiet sculptor of the cosmos. Isaac Newton, centuries ago, described gravity as a force that draws all masses together, proportional to their mass and inversely proportional to the square of the distance between them. This simple law, so elegant and so profound, is the architect of planetary orbits, the reason why the moon clings to the earth, why the earth circles the sun, and why the sun itself is bound to the vast spiral arms of the Milky Way. Yet gravity is not the only player in this galactic waltz. The sun, though massive, is only one among billions of stars, each with its own retinue of planets, each tugged upon by the collective gravity of the galaxy. The Milky Way, like a living organism, is a swirling disk of stars, gas and dust, all orbiting a mysterious center. Its spiral arms are not solid structures, but rather regions of higher density, where stars are born, live and die, swept along by the tides of galactic motion. The sun's orbit around the galactic center is not a perfect circle. It is slightly elliptical, a gentle oval that brings it closer to and then farther from the heart of the galaxy over the course of its journey. The full circuit takes about 225 million years, a span so immense that in the time since the dinosaurs first appeared on Earth, the sun has completed only a single galactic orbit. The solar system, then, is not a static fixture, but a fleeting passenger, whirling through a galaxy that itself is in flux. Within this greater motion, the planets perform their own intricate steps. They orbit the sun in paths that are nearly, but not exactly, circular. Mercury, closest to the fire, traces a more elongated ellipse, while the outer giants sweep through broader, slower arcs. Each planet's orbit is governed by a balance between gravitational attraction and the inertia of its motion. If a planet moves too slowly, it will spiral inwards, drawn inexorably toward the sun's fiery surface. If it moves too quickly, it will break free and wander into the darkness, lost to the cold reaches between the stars. This balance is not mere happenstance. It is the result of ancient collisions, gravitational tugs, and the primordial cloud of gas and dust from which the solar system was born. Over billions of years, chaos has given way to order, but the system remains finely poised, each world dancing on the knife edge between falling and flying away. Even the planets are not alone in their motion. Many harbor companions, moons, some tiny and battered, others large enough to be worlds in their own right. These moons orbit their planets while both are carried forward by the sun's motion, creating orbits within orbits, cycles nested inside cycles. The complexity of these layered motions is staggering, yet the mathematics that describe them are precise, allowing us to predict eclipses, tides, and the positions of planets with astonishing accuracy. Consider, for instance, the path of the Earth's moon. It orbits our planet at a distance of roughly 384,400 kilometers, completing one circuit every 27.3 days. But this orbit, too, is not a tidy circle. It is slightly elliptical, and it wobbles over time due to the gravitational pull of the Sun and other planets. As the Earth and Moon together orbit the Sun, and as the Sun moves through the galaxy, the Moon's path traces out a complex braided pattern, a lacy spiral wound around a vast, invisible thread. Extend this vision outward, and the scale becomes more daunting still. The solar system is not isolated. It is surrounded by a halo of icy objects, the Oort cloud, that may stretch nearly halfway to the nearest stars. These distant bodies, comets and frozen relics of the solar system's birth, are bound to the Sun by the faintest whisper of gravity. Occasionally, one is jolted from its slumber by the passing gravity of a distant star, or the tidal forces of the Milky Way itself, sent tumbling inward on a long, slow arc that can take millions of years to complete. When such a comet finally nears the Sun, it erupts in a plume of vapor and dust, a ghostly messenger from the edge of our solar domain. All these motions, the turning of planets, the sweep of comets, the Sun's great galactic voyage, invite us to reconsider what it means to move, what it means to be still. In everyday life, speed is measured against the ground beneath our feet, the floor of our homes, the surface of our planet. But in the cosmic perspective, these are all relative. There is no absolute stillness, only the intricate web of motions nested within larger and larger cycles. Even as you sit quietly, reading or listening, you are a passenger on a world that spins on its axis, orbits its star, and follows that star through the spiral arms of the galaxy. The very concept of speed becomes slippery in space. Relative to the Sun, Earth's velocity is 30 kilometers per second. Relative to the center of the Milky Way, the Sun's velocity is 220 kilometers per second. But what is the Sun's speed relative to the stars beyond our galaxy? The Milky Way itself is moving, gliding through the universe at several hundred kilometers per second, drawn by the gravitational pull of neighboring galaxies, caught in the slow, majestic flow of cosmic structure. In this way, motion is always measured against something else. There is no absolute reference frame, no cosmic anchor from which to declare, here is true stillness. Every object moves, every object is moved. The dance of suns, planets, and galaxies is endless and universal. Yet within this endless motion there are patterns, rhythms and harmonies that lend order to the seeming chaos. The planets return to their positions with regularity, marking out the years and seasons. Comets sweep back in after long absences, their appearances catalogued and foretold. Eclipses recur in cycles, the shadow of the moon tracing the same path over the Earth's surface after an interval of years. These patterns are the music of the spheres, the great symphony of cosmic motion, but not all is perfectly regular. The solar system is subject to disturbances, both subtle and dramatic. The gravitational effects of passing stars, the tidal forces of the galaxy's spiral arms, even the gentle drag of interstellar gas can nudge the orbits of comets and planets, setting off slow, unpredictable changes. Over millions of years, these small perturbations accumulate, and the solar system's architecture shifts and evolves. Even the sun itself bobs up and down as it orbits the galactic center, rising above and dipping below the dense plane of the Milky Way in a slow, rhythmic oscillation. As we peer deeper into the spiral dance of suns, our sense of motion and stillness, of speed and rest, is forever altered. The universe is revealed not as a static tapestry, but as a living, moving thing, a grand, ongoing performance of gravity and inertia, of light and shadow, of cycles within cycles. The sun is both a source of warmth and life, and a voyager, pulling us ever onward through the starlit reaches of our galaxy. And so we drift, not merely around our star, but through the luminous spiral arms of the Milky Way, each revolution a journey into the unknown. As the sun traces its immense circle around the galactic core, it carries us with it, across cosmic seas, beneath the light of 100 billion stars, through regions of darkness and clouds of glowing gas. The spiral dance continues, unending, unresolved, inviting us to look further, to wonder at the mysteries that lie ahead and the hidden forces that guide our cosmic voyage. To measure what seems inherently unmeasurable is a challenge that has summoned the best of human ingenuity for centuries. There is something deeply paradoxical about seeking to know our speed and motion through the galaxy, for we ride within the very vessel whose movement we hope to grasp. We are passengers on a ship whose deck is so vast, whose sweep so slow and steady, that its motion eludes our senses entirely. The ancient mariners of Earth could sense the wind in their hair, the tilt of the deck beneath their feet. But the cosmic sea through which our solar system sails is silent, cold, and dark, offering no gusts or swells to betray our passage. Yet the urge to know, to measure and to understand has always pressed humanity onwards. Long before telescopes or satellites, before the faintest glimmer of galaxies reached our eyes, thinkers wondered, does the sun itself move? And if so, how fast, and toward what distant shore? The earliest inklings of such questions trace back to the dawn of astronomy. Ancient observers watched the stars wheel overhead and imagined them as fixed lanterns on a celestial dome turning around an unmoving Earth. The heliocentric revolution, ushered in by Copernicus and Galileo, shifted the seat of cosmic motion outward. Now the sun, not the Earth, was the center of planetary dance. But even as the solar system became a system in motion, the stars were still thought to be fixed and unmoving, a static backdrop. Only later, as telescopes grew more refined, did astronomers begin to suspect that the sun, too, might be a wanderer through the heavens. The first hints came from the phenomenon of proper motion, the slow, steady drift of stars relative to one another as seen from Earth. In the early 18th century, Edmund Halley, famed for his comet, compared the ancient star catalogues of Hipparchus and Ptolemy with his own observations. He found that some bright stars, like Sirius and Arcturus, had shifted their positions minutely over centuries. The stars were not fixed after all, but moved with glacial slowness. From these subtle motions, astronomers deduced that the Sun and solar system must themselves be travelling through space. But how to measure that motion? To do so required an extraordinary leap. To use the stars themselves as markers, to treat their scattered patterns as a kind of celestial current against which the movement of our own solar system could be measured. The 19th century brought calculations and conjectures, but no certainty. It was William Herschel, the great discoverer of Uranus, who first attempted to pin down the sun's path. Herschel reasoned that if the sun was moving through a sea of stars, then those in the direction of its motion would appear to crowd together, while those behind would seem to spread apart like snowflakes in the beam of a moving carriage. By measuring the motions of many stars, he hoped to locate the apex of the sun's way, the point in the sky toward which our solar system travels. Herschel's instruments were crude by modern standards, and his proper motion data sparse, but his method was sound. His calculations pointed roughly toward the constellation Hercules, and though his precise numbers were off, the principle was established. The sun is not still, but plunges ever onward through the galaxy. The quest for greater precision drove astronomers to refine their observations and invent new techniques. The trouble was that proper motion alone could only reveal the motion of stars across the sky, not their approach or recession. To disentangle the solar system's motion from that of the stars themselves required a way to measure the third dimension, the line of sight velocity, toward or away from us. The answer came, as so often in science, through an accidental discovery. In 1842, the Austrian physicist Christian Doppler presented a paper to the Royal Bohemian Society proposing a curious effect, that the color or frequency of waves would shift if the source moved relative to the observer. The Doppler effect is familiar now in the rising and falling pitch of a passing siren, but in Doppler's day it was a revelation. Within years, astronomers realized that the spectral lines of starlight, those fine, bright bands revealed by the new science of spectroscopy, could be used to measure the velocity of stars by noting their redshift or blue shift. Armed with this tool, astronomers began to chart the true motion of stars in 3 dimensions. They measured the radial velocities of hundreds of stars, combining them with proper motion data and distances. Slowly, a picture emerged. The sun, and with it the whole solar system, was moving through the local star field at a measurable speed. The process was painstaking, riddled with uncertainties and errors. Distances to stars were poorly known, their own motions tangled and obscure. To correct for these, astronomers employed statistical methods, measuring the motions of many stars and averaging out their individual paths to reveal the common drift of the sun. By the early 20th century, the consensus was that the sun was moving at a speed of about 20 kilometers per second, or 72,000 kilometers per hour, toward a point in the sky near the bright star Vega in the constellation Lyra. But these numbers, while impressive, told only part of the story. They measured the sun's motion relative to nearby stars in our galactic neighborhood, the so-called local standard of rest. But what of the broader movement, the grand orbit of the solar system around the center of the Milky Way? This was a deeper challenge, for the center itself was invisible, shrouded by dust and distance, and the stars of the galaxy moved in their own orbits, making the cosmic current difficult to chart. In the early 1900s, a young astronomer named Jan Oort took up the challenge. Oort realized that the motions of stars in the galaxy could be used to probe its structure and the motion of our own solar system. By measuring the velocities of stars at different positions in the sky, he deduced that the Milky Way rotated, carrying the sun and its planets along a vast circular path. Using careful analysis, Oort estimated the speed of the sun's galactic orbit, about 220 kilometers per second, or nearly 800,000 kilometers per hour, a breathtaking velocity, far greater than our earlier estimates. This measurement came not from direct observation, but from a kind of cosmic triangulation. Oort's method relied on mapping the radial velocities and positions of many stars, and fitting them to a model of galactic rotation. By finding the pattern of motions that best matched the data, he could infer both the sun's speed and its distance from the galactic center. This was science at its most ingenious, extracting the motion of our own cosmic ship by watching the eddies and swirls in the wake of countless other travelers. As the 20th century progressed, new tools emerged to refine these measurements. The advent of radio astronomy opened a new window on the galaxy, allowing astronomers to peer through the dust that veiled the Milky Way's heart. By tracking the emission of neutral hydrogen gas, which emits radio waves at a precise wavelength of 21 centimeters, they could map the rotation of the galaxy with unprecedented clarity. The technique was subtle but powerful. Clouds of hydrogen gas orbit the galactic center, and their motion can be measured by the Doppler shift of their radio emissions. By mapping these velocities across the sky, astronomers built a detailed picture of the Milky Way's rotation curve, the way its speed varies with distance from the center. From this, the Sun's own orbital speed could be measured with remarkable precision, confirming Oort's earlier estimates and revealing further mysteries, such as the presence of vast quantities of unseen dark matter that held the galaxy together. The story of measuring the solar system's motion is not only one of telescopes and spectroscopes, but of mathematical ingenuity and patient accumulation of data. Each step forward required new instruments, new methods, and above all, the willingness to question assumptions. The distances to stars, once guessed at by their brightness, were pinned down by the method of parallax, the tiny shift in a star's position as the Earth moves around the Sun. The proper motions of stars, once measured by painstaking hand, are now tracked by automated telescopes and space observatories, mapping millions of stars with exquisite precision. In recent decades, this quest has reached new heights with the launch of dedicated astrometric satellites. The Hipparcos mission, launched by the European Space Agency in 1989, measured the positions and motions of over 100,000 stars, refining our knowledge of the Sun's path through the galaxy. Its successor, the Gaia mission, is now mapping more than 1 billion stars, providing a three-dimensional atlas of the Milky Way and revealing the intricate dance of stars, gas, and dark matter that shapes our galaxy. But perhaps the most poetic method of all comes from the study of the cosmic microwave background, the faint afterglow of the Big Bang itself. This ancient light, bathing the universe in a chill, uniform glow, serves as a reference frame for all motion in the cosmos. When astronomers measured the microwave background in all directions, they found a tiny but measurable difference. The glow is slightly hotter in the direction of the constellation Leo and slightly cooler in the opposite direction. This dipole anisotropy reveals that the solar system is moving at about 370 kilometers per second, relative to the primordial light of the universe. Here, at last, is a true cosmic milepost, not the bustling swirl of the galaxy, nor the shifting patterns of nearby stars, but the echo of creation itself. Our motion through the universe is written in the very fabric of the sky, a faint tilt in the afterglow of the Big Bang. To measure this is to measure our passage not just through space, but through time. Yet even now, the act of measuring the unmeasurable remains a work in progress. Each tool, each technique, offers a different perspective, a different reference frame, a different kind of motion. The Sun's journey relative to its neighbors, its orbit around the galactic center, its plunge through the cosmic background, all are true and all are incomplete. The universe is a hall of mirrors, and each measurement reflects a different aspect of our motion. The ingenuity required to capture these faint motions is humbling. Consider the patience required to trace the proper motion of a star over centuries, or the technical wizardry needed to build a radio telescope sensitive enough to detect a whisper of hydrogen across the galaxy. Contemplate the boldness of the idea that light itself, stretched by motion, can serve as a ruler to measure the speed of our solar system through the vastness of space. Still, the search continues. Each new generation of astronomers builds on the legacy of those who came before, refining the measurements, probing deeper, seeking new ways to pierce the veil of cosmic motion. with every improvement in technology, every new survey of the heavens, our picture of the solar system's journey grows sharper and more profound. And yet, as we measure, as we chart and record and analyze, the mystery deepens. For even as we learn to measure our speed with astonishing precision, the question of what lies ahead, of where our journey leads, remains open. The galaxy itself is a restless ocean, its stars and clouds swirling in great tides and eddies. The sun, with its retinue of planets, is but one voyager among billions, its path shaped by forces we are only beginning to understand. So, as the instruments grow ever more sensitive, as our cosmic maps become ever more detailed, the sense of wonder persists. Each measurement is a window, a glimpse of our place in the grand procession of the cosmos. We are passengers on a moving world, carried along by currents vast and unseen, our speed written in the shifting starlight and the faintest whispers of ancient photons. And as we drift onward, our eyes turn to the future, to the questions that remain. What else might we learn as we refine our measurements still further? What new techniques might reveal the secrets of our cosmic journey? The story of measuring the unmeasurable is not yet finished. It continues, a thread woven through the tapestry of human curiosity and ingenuity, inviting us to look deeper, to ask more, to wonder, always to wonder, at the motion that carries us through the night. Out beyond all familiar boundaries, there is a silence that envelops the mind, a hush so vast it is almost a presence. It is in this silence that we find ourselves, night after night, gazing upward from our small blue world. The sky, scattered with its ancient fires, invites questions too big for words, yet we cannot help but try to shape them, to give form to our awe. We are voyagers, stowaways upon a planet that spins and careens not only through the softness of its own atmosphere, but through the immense black of space, itself a sea with no horizon. To understand our place, our true place, among the wheeling galaxies, is to feel the weight and the lightness of being a speck in the cosmic sea. What does it mean truly to be carried through the galaxy? The notion is both literal and metaphorical. With every second, the earth rotates beneath our feet, turning us toward the dawn. Simultaneously, Earth orbits the sun, circling that yellow star in a looping, elliptical dance, but even this is only a fragment of the story. The sun, too, is adrift, carried along by the swirl of the Milky Way, which itself is just one amongst billions. It is as if we are riding a raft on a river, while the river itself is winding through a landscape, and the landscape is shifting in a world without end. There is no center, no fixed point to anchor our journey. We are always in motion, always in flux, cosmic nomads without a map. The distances involved in our galactic voyage are so immense that they defy ordinary comprehension. Light, which can circle our Earth 7 times in a single second, takes more than 4 years to reach even the nearest star beyond the Sun. And yet, as the Sun orbits the center of the Milky Way, carrying its planetary family in tow, it moves at an astonishing pace, roughly 220 kilometers per second. In the time it takes you to read this sentence, our solar system has traveled hundreds of kilometers through the galactic dark, accompanied by the silent procession of comets, asteroids, and drifting clouds of interstellar dust. Every living thing on Earth is a passenger on this journey. The trees in the forest, the fish in the sea, the birds that migrate across continents, each one is swept along in the same invisible tide. Even the rocks and the mountains, seemingly so steadfast, are travelers, their atoms tracing arcs through the spiral arms of the Milky Way. Human beings, with our cities and our histories, our laughter and our grief, are no less adrift, no less part of the grand migration. We are, in the most literal sense, children of the galaxy, our atoms forged in ancient stars, our lives unfolding against a backdrop of perpetual motion. This realization can be unsettling. The scales of time and space involved are so vast that they threaten to dwarf our hopes, our fears, our sense of importance. Yet there is a strange comfort, too, in knowing that we are not separate from the universe, but an expression of it. The iron in our blood, the calcium in our bones, the carbon that forms the backbone of our DNA, all were formed in the hearts of stars that lived and died long before our sun was born. We are, as Carl Sagan once so beautifully said, star stuff, contemplating the stars. Consider for a moment the history embedded in your very body. Each atom is a relic, a survivor of cosmic upheavals. Hydrogen atoms, the simplest and most ancient, were born in the first moments after the Big Bang, over 13 billion years ago. Other elements have a more violent pedigree. Carbon, oxygen, and nitrogen were forged in the nuclear furnaces of massive stars. Iron was created in the catastrophic collapse of supernova. When you breathe, you draw in air laced with atoms that may have once resided in the lungs of dinosaurs, or travelled through primordial clouds of gas before the Earth condensed from the solar nebula. When you look up to the glittering band of the Milky Way, you are seeing not only the present but the deep past, a tapestry woven from the remnants of 1,000 suns. There is humility in this perspective. For all of our technological prowess, all our cleverness and ambition, we are still bound by the same physical laws that govern the orbits of planets and the collapse of stars. Our lifespans are brief, our civilizations mere flashes in the cosmic night. The galaxy neither knows nor cares for our dramas, our empires, our sorrows. And yet, within this humility, there lies a profound sense of belonging. The fact that we are small does not make us insignificant. Rather, it makes our existence all the more precious, a fleeting spark in an infinite darkness, a brief flowering of consciousness on a world in motion. This sense of scale can provoke a kind of vertigo, an existential dizziness. The mind reels at the vastness of the universe, at the enormity of time. But there is a counterweight, a gravity that pulls us back toward meaning. It is the knowledge that against all odds, life has arisen on this planet, and with it, the capacity for wonder. We are, after all, the only creatures we know who can ask these questions, who can ponder our place in the cosmos. The atoms that make up our brains have, through the slow process of evolution, organized themselves into patterns that can reflect on their own existence. We are the universe becoming aware of itself. Our journey through the galaxy is not a solitary one. All around us, other stars are moving, tracing their own paths through the spiral arms. Some are young and hot, blazing with the fierce light of early youth. Others are old and dim, nearing the end of their long journeys. Occasionally, stars pass close enough to disturb the orbits of comets in distant clouds, sending icy bodies plunging inward toward the warmth of the sun. Over millions of years, these stellar encounters have subtly shaped the architecture of our solar system, and perhaps even influenced the course of life on Earth. The very fact that we are here, that a planet with the right conditions for life happened to form around a stable star in a relatively quiet corner of the galaxy, is the result of a long chain of cosmic accidents. Change any link in the chain, and the outcome might have been entirely different. The Sun could have formed closer to the crowded galactic center, where supernovae and black holes abound, and where life would have faced a constant barrage of deadly radiation. Or the solar system might have passed through a dense molecular cloud, stripping Earth of its atmosphere and sterilizing its surface. The fact that we exist on a world warm and wet and teeming with life is a kind of miracle, a rare alignment of chance and necessity played out on a cosmic scale. And yet, even as we marvel at our good fortune, we are reminded that nothing lasts forever. The sun, for all its apparent constancy, is slowly changing, burning through its supply of hydrogen in the slow fusion that gives life to our world. In another 5 billion years, it will exhaust its fuel and swell into a red giant, engulfing the inner planets and scattering their remnants into space. Long before then, the shifting tides of the galaxy may have altered the solar system's orbit, or a passing star may have perturbed the Oort cloud, sending a rain of comets toward the inner planets. The galaxy is not a fixed stage, but a restless ocean, its currents and eddies forever reshaping the destinies of stars and worlds. It is in this context that our brief lives take on their true meaning. We are here for an instant, borne along by forces we can barely comprehend, yet in that instant we have the capacity to create, to love, to dream. Our art, our science, our music, all are attempts to reach beyond ourselves, to touch something eternal. When we send telescopes into orbit or dispatch probes to the outer planets, we are not only seeking knowledge, but affirming our connection to the cosmos. We are saying, in effect, we are here. We have seen the stars, and we wish to know them. The movement of the Earth through the galaxy is not something we feel directly. We do not sense the tug of the Sun's gravity or the slow arc of the solar system around the galactic core, but there are subtle reminders if we know where to look. The cosmic microwave background, the afterglow of the Big Bang, washes over us, bearing the imprint of the universe's earliest moments. Streams of cosmic rays, accelerated by distant supernovae, bombard our atmosphere, occasionally causing mutations that shape the course of evolution. Even the gentle light of the Milky Way, arching overhead on a clear night, is a record of our journey, a snapshot of the spiral arm through which we are passing, and a glimpse of the path we have yet to travel. For millennia, human beings have looked to the stars for guidance, for inspiration, for meaning. We have woven stories and myths to explain their patterns, charted their motions, and measured time by their rising and setting. Today, our understanding is deeper and more precise, yet the sense of wonder remains undiminished. The more we learn about the universe, the more we realize how much remains unknown. There are questions that may never be answered, mysteries that will endure for as long as there are minds to ponder them. Some may find this uncertainty unsettling, but there is a quiet joy in embracing the unknown. It is an invitation to humility, a reminder that our knowledge is always provisional, always subject to revision. The universe is not obligated to conform to our expectations. It is what it is, and it is far stranger and more beautiful than we can imagine. Each new discovery is a window into the unknown, a chance to glimpse the intricate machinery of creation. In the end, to be a speck in the cosmic sea is not to be lost, but to be found. It is to recognize that our lives, though brief, are part of a larger story, a story written in starlight and shadow, motion and stillness, chance and necessity. We are not the center of the universe, but neither are we its afterthought. We are, for this brief moment, the universe reflecting on itself, marveling at its own existence. And as we continue our journey around the sun, through the galaxy, and into the unknown, we carry with us the gifts of curiosity and wonder, the spark that sets us apart and binds us to all that is. So, as you drift towards sleep, let your thoughts wander outward, beyond the walls of your room, beyond the atmosphere, through the silence of space. Picture the earth, a blue marble turning in the dark, and feel the gentle pull of the sun, the slow, stately procession of the planets, the swirl of the spiral arm, the wind of the galaxy. You are part of this, forever and always, a child of stars, a voyager in a universe without end. The story continues, written in the language of motion and light, waiting to be discovered anew with every dawn. As our journey through the swirling currents of our solar system's cosmic voyage gently drifts to a close, may your thoughts float like stardust carried on a comet tail fading into the hush of space. Rest peacefully beneath the vast galaxy's quiet glow, and when you're ready to dream anew, return for more whispered mysteries from the endless night.